Good afternoon, class. This is your favorite statistics teacher here, Mr. Ireland. We are all set and ready to go with our distance learning today for our COVID-19 break. So we're going to pick up here on the central limit theorem in chapter 6.6. We started this, I want to say last Thursday, talked about a little bit on Friday. It was a crazy week. But we're going to finish it today, and we are going to have a review tomorrow, and I am going to give you guys an online test that you are going to have to do over the course of Wednesday and Thursday. Okay, Wednesday and or Thursday. There will be a time limit, so you'll just have to pick what day you want to take it on, and you're going to have to get that finished in a limited time frame. It will be open notes, of course. All right, without any further ado, let's get started with this. So the objective here is we're going to determine if the sampling distribution of X bar is approximately normal when sampling from a non-normal population. So we're going to get a little bit into this, but here you see three different parent populations. Here you've got a uniform distribution, here you've got a right skewed distribution, and here you've got this strange looking symmetric distribution. But again, notice these are not normal population distributions. So an activity we were going to do in class is we were going to investigate what happens as we take samples of n equals 2. And we were going to look at what the sampling distribution started to look like. As you can see here, it's uniform, which is symmetric. You get this symmetric looking distribution at n equals 2. But the larger n gets, down here when you get to 25, you get this approximately normal looking shape. Same thing, you take a skewed population, and let's say you take samples of n equals 2. Now, your sampling distribution will still be skewed right, but it won't be as strongly skewed as the original population. Now, if you take sample size of 25 and getting larger, again, you would get what looks like a nice normal distribution. I'm trying to use my pen tool here, and it's not working so great. Let's see. There we go. Ooh, that is very ugly, but you guys get the point. Now, even on this parent population, which has got this very strange shape, symmetric but very strange looking, as you can see at n equals 2, you get funny looking sampling distribution, but once you get up there to the mid-20s, you start to get a very normal looking distribution. Alright, let's move on here. We watched this video in class, so I will post a link on Google Classroom if you need to take another look at it again. It's a good explanation of what the sampling distribution of a sample mean looks as you increase your sample size. Alright, and this is a theorem. It was called the central limit theorem that I had you guys write in class on Friday. So I'm not going to spend too much more time with that. But I did want to talk about the normal large sample condition. So the normal large sample condition says that the distribution of X bar will be approximately normal when either of the following is true. The population distribution is already approximately normal. If that's the case, then the sampling distribution will be normal. Also, if the sample size is large. Okay, what do we mean by large? By large, we mean n greater than or equal to 30. Now, as you saw in the previous slides, even by n greater than or equal to 25, we start getting a sampling distribution that's approximately normal. But once you get to 30, chances are you do get a nice approximate normal distribution. Alright, let's move on here. So let's try that out in a problem. You guys might hear my kids in the background. Please excuse them. They're just coloring. Trying our best here to do this whole distance learning, learn from home. So don't mind them. Alright, so let's take a look at this problem here. Now, we have a very heavily skewed right population distribution. And this is a distribution for the opening weekend earnings for movies in 2016. So back when Civil War came out and other classics like La La Land, you know, back before we had this COVID-19 to worry about, you know, those are the movies that were out. And we have this very heavily skewed right population. Some movies make a lot of money in their first opening weekend, whereas most don't. So we've got a skewed right distribution. So here goes the question now. So question is, describe the sampling distribution of X bar for SRSs of size n equals 60 and justify your answer. Part B is describe the shape of the sampling distribution of X bar for SRSs of size n equals 10. Alright, so let's take a look at our solution. Now remember, the central limit theorem, very, very important. The central limit theorem tells us that once n is larger than or equal to 30, our sampling distribution will be approximately normal. So this deals with the shape. So this refers to the shape, and it will be approximately normal. Now in this second problem, n is equal to 10, which is less than 30. So your sampling distribution is going to be skewed right, but not as strongly as the population. So your sampling distribution is still going to be skewed. It just will not be as heavily skewed as this that you see here. Okay, but once you get 30 or more, you are going to have a sampling distribution that is approximately normal. All right, we're going to move on here. So now let's get into some probabilities. So now we're going to bring in back some of those z-scores and normal CDF and all that good stuff that we talked about. So here's a question that we're going to try out together. Suppose that the number of texts sent during a typical day by the population of students at a large high school follows a right-skewed distribution with a mean of 45, a mean of 45 and a standard deviation of 35. And it does say that the population is right skewed. You've got some students that send a whole lot of texts per day, and you've got a lot of students who are not sending as many. So you've got a right skewed distribution. Now, how likely is it that a random sample of 100 students, n equals 100, will average at least 50 texts per day? All right. So let's try this out and calculate the center, spread, and shape. All right, so as you can see here, the mean is 45 because that's the mean that's given. So our mean, mu of x bar is 45. Our standard deviation is 35. Now remember, this formula comes from one we talked about earlier in this chapter. It's your sample standard deviation divided by radical n. So that's where these numbers are coming from. So you take 35 and you divide it by radical 100. Remember, there's going to be a lot less variability for 100 students as there is for 1. So you're going to have a much smaller standard deviation than you would for your population. So our SD is 3.5. Now our shape is approximately normal by the CLT because n equals 100 is greater than or equal to 30. All right? So now this is very important. This CLT is important because now it allows us to use z-scores and normal CDF and all that other good stuff. All right, so now here comes the z-score portion. On this part, we are finding the probability. I'm sorry, guys, I'll get the hang of this one day. So here, we're going to find the probability that the mean x bar is greater than or equal to 50. So here's our z-score. So remember, 50 goes there. That's like our value minus the mean. Divided by the standard deviation of 3.5. I'm sorry, guys. My kids, gotta love them. Z-score is 1.43 if you do all of that correctly. Now notice, look at the normal curve to your right. So it's very helpful to draw so you know which way to set your calculator work up here. So right here it's normal CDF, lower 1.43, upper 999, mean 0 SD1, giving you a percentage or probability of 0.076, or about 7.6%. Now, a lot of you guys don't have calculators at home, I understand. So here's how you're going to set this up. So you're going to go back to our favorite site, Staplet. Let me get out of here. So we're going to go to our favorite site, which is Staplet. www.staplet.com, 2 P's. Go over to normal distributions. And you want to calculate an area under the normal curve. Alright, so the mean you want to keep at 0, 1. That's a standardized mean of 0 and an SD of 1, the standard normal curve. Alright, plot that distribution. You don't want the area between two values. You want the area to the right of a value. And in this case, it's our z-score of 1.43. And you hit calculate area, which gives you an answer 7.64, which is this answer that you see down here. Okay, as you can see, it matches that perfectly standardized. Now, there's a way you can do it by inputting all the other values. I'll let you guys figure that out for yourself. I don't want to have you rely too much on the technology, so you guys are smart. You can figure it out on your own if you really want to do it the other way. All right, last example, you guys, because I've got to get back to my kids before they go crazy here. So this very last problem here, we are going to look at the probability of a random sample of 50 of these movies, going back to that 2016 opening weekend movie example. What is the probability that a random sample of 50 of these movies will have an average opening weekend earnings of less than 19 million? So that translates to probability that X bar, let me go back one slide, that translates to the probability of X bar being less than 19. Okay, so just like in the last example, you want to find the mean of your sampling distribution, which is 26.2. You want to find your standard deviation, which is the population standard deviation divided by radical n. Let me write that out one more time. Okay, and that gives you 3.24 million. And the shape is approximately normal by the CLT because the key number here is 50, a sample of 50, which is much larger than 30. So we are good to go. All right, now we're going to find the z-score again here. So your z-score, plug that number right in there. This is your mu that you get from above. This is your standard deviation that you get from the SD portion. Here, this goes here. You get your z-score of negative 2.22. Now, because of the word less than in that problem, as you can see, your normal CDF is negative 999 for your lower. Your upper is negative 2.2, and you've got a mean of 0 and SD of 1, giving you a probability of 0.0131. Okay? So again, if you want to do this on Staplet because you don't have a calculator, I'm going to quickly show you how this works. So you are going to go to Staplet, go back to that normal distribution portion, and you have to have an idea of where the shading goes. So you calculate an area under the curve. This time we want to go to the left of a value. And the value in question is negative 2.22. Click on area. We get a value of 1.32%, which if you look here is it's a little bit different from what I answered here. We've got an answer of of 0.0131, but that's a very, very minor difference and doesn't make that much of a difference. Not a big deal. All right, honor statistics. Looking forward to working with you guys some more virtually. Let me know if you guys have any questions. Send me a Schoology message, Google Classroom message, email, whatever you'd like. I'm going to sign off now. Check Google Classroom for your homework.